I think it's a good time to start. Uh, well, first of all, good afternoon, everybody, and welcome to the first webinar held together between the Flexor Factory, Trinoflex, and Flex Industries project. The title of the webinar is Unlocking Energy Flexibility for Sustainable Industrial Processes. I am Marco Barbagelata from STAM. I am the Digital Transformation Officer of STAM, and I will try with the colleagues from Sintef and the Violet project partners to kind of run you through this webinar. Uh, I will start with introducing real quick the goal of the webinar itself that, as you see from this slide, is kind of taking you through three projects called Flexor Factory, Flex and Flex Industries. They all respond to one European call for action, call for projects actually, that happened in 2021 called Design and Optimization of Energy Flexible Industrial Processes. Uh, these were the three projects that were awarded, and our goal today is to present to you the state of these projects, not as single, projects with their own work packages and so on, but more of kind of a cluster of projects that are working to solve the same problem. And so we will try to find similarities as much as possible. We will try to find differences, and we will try to kind of reflect based on the story that we tell today. So how it's going to go is, of course, I will have help and support from the guys that you see on top. So we will start with the expert talk that is going to set the mood for the speeches. It's going to be by an expert speaker called Hannes Stahl from Statnet. And then each project is going to have an introduction to the project, technical introduction, and then the presentation of a use case, basically. So this is very, very quickly what we will discuss. So focusing on the flexibility of industrial processes. Why does it matter? Because we are committing to goals that say that on one side, we will be more efficient from an energy point of view, we will be less impactful from a CO2 point of view. And on the other, we say that this is going to happen while we're growing economically, while we're growing, as a continent in terms of GDP as well. So these two goals, of course, kind of might be contradicting. Our goal today is to prove that there are some approaches that will not have them contradicting. So we will start from the very first speech that is going to be the increased need for flexibility in the power system. And I leave the floor to Hanna, please.
Thank you very much. I just try to take control of the presentation. So my name is Hanne Stahle. I'm a senior advisor at Statnet, which is the Norwegian transmission system operator. And we have a large focus on flexibility and the need for flexibility in the power system. And also we want to include more stakeholders contributing with flexibility, because in the Norwegian power system, there is already flexibility available from large hydropower plants and also large industrial customers. But we see that we also need flexibility from new stakeholders. So we have recently published a report on flexibility, but that is in Norwegian, but the main topic from that report is translated to English in this presentation. So why do the power system needs more flexibility? So what we see is the need for flexibility is increasing, and we need also flexibility delivered from both consumption and generation stakeholders that has not contributed with this previously. And the need for flexibility is due to the increase in electrical consumption due to electrification of transport, for example, and also the increase of weather-dependent generation based on renewable resources such as wind and solar. So the power system needs flexibility, both with fast response that can react within seconds, and also flexibility that can deliver energy for a longer period, which can be days or months. The power system needs flexibility from new stakeholders because the situation in the power system is changing. So we need more stakeholders than not only the hydropower plants. And also the use of local flexibility can contribute to improved grid utilization and also earlier grid connections for new customers. It's a delay in when I try to activate the animation. So there are several incentives to activate or stimulate for flexibility, but it is important with good coordination to realize large enough volume, but also diversity of flexibility. So in our work, we have defined flexibility as the ability that both producers, consumers, and energy storage have to adjust the generation, consumption, and/or storage of energy, and that should be as a response to the status of the power system. And flexibility is important for the power system, both for grid operation, for example, for balancing the power system. There should always be a balance between consumption and generation. And also using flexibility for congestion management in the grid and also handling grid problems, for example, such as voltage problems. But flexibility is also important for power system related to grid planning. If we have flexibility, then that can give customers the possibility for earlier grid connections. And in some cases, it can also defer specific grid investments. So flexibility for the power system, flexibility can contribute both to security of supply, but also improved utilization of grid and resources. So first, related to balancing, I've mentioned that balance between generation and consumption is important to keep the stability of the power system. And that is valid even if it's limited or too much generation. In periods with larger generation from solar and wind farms, then to solve this, perhaps the flexibility should be to increase the consumption. In periods with scarcity of generation, the solution can be to reduce the consumption. The second is utilizing flexibility to contribute to improved resource utilization. That's also to have flexible demand available when there is generation from variable renewable sources. And the third, flexibility as a response to high energy prices and also as a response to grid tariff that can contribute to improved utilization of the existing grid. If you can reduce peak load and more flatten consumption, that will be a benefit for the grid. And in some cases, it can reduce the grid investments. So to give an overview, to utilize flexibility in the power system, a holistic approach is important. We need business models to stimulate for increased flexibility. So this picture shows the flexibility value chain from the flexibility provider to the left, showing flexibility. Some sounds. You have the flexibility provider to the left, and you will have the flexibility procurer to the right. And the flexibility provider can be different types of customers. It can be large industrial customers, but it can also be smaller customers, office buildings, and even on household level. And the flexible resources, it can be from generation, solar panels or wind farms, but it can also be electric batteries connected to the grid or behind the meter at the customer side. And it can also be flexibility from different types of loads. In this picture, I showed it with use of an electrical vehicle, but it can also be water heaters or electric boilers, or even air condition, heat pumps. For the flexibility procurer, that is the DSO, this is the distribution system operator, or the TSO, the transmission system operator. They need flexibility for operating the grid. As I said, it can be for balancing, it can be for congestion management, and it can also be utilized for voltage control. And the TSOs, for example, have several balancing markets where flexibility can be bid into these markets and activated when there is a need for flexibility in the power system. So we have the provider and we have the procurer, but we need something in between to realize these, to match these, the need and the offers, and that is we need business models and service providers. And that can be aggregators and markets, balancing markets, so flexibility markets. So these new stakeholders can also developing incentives for activating flexibilities. But it is important that all the stakeholders included in this value chain will benefit from utilizing flexibility. And also technical solutions is an important part here for both for realization and activation of flexibility. Because to secure fast enough response of flexibility, it is important with different types of control system, for example, enabling this. And in total, you can see at the bottom, we have a specified regulatory framework. It is important with proper regulatory framework enabling increased utilization of flexibility that we have. That is to secure that it is possible to develop sufficient incentives and business models that both stimulates to activating flexibility, also for buying flexibility. So this is the value chain related to flexibility. So increased need for flexibility can give new possibilities. And we have studied this as seen from the power system in general, but also from Statnett. Because there is an increased need for different types of flexibility. And as we see, the trends in the power system, a more demanding grid operation will increase the benefit of utilizing flexibility, both for existing stakeholders offering flexibility, but also for new stakeholders. Because in periods there are limited flexibility available from the large hydro plants because most of the consumption is supported by electricity generated by, for example, solar panel. So where do we then get the flexibility? So, and also flexible consumers can contribute solving challenges related to this, to periods or areas where limited grid capacity. Oh, I lost the control. I have to. So for the flexibility provider, we as Statnett, we inform about their increasing need for flexibility in the power system. And that is it's a more an invitation, to give incentives or give information that there are possibilities for new stakeholders to offer flexibility into the balancing markets. And also flexible consumers, they can save money, for example, reducing load in periods with high prices, but also as a payment for selling flexibility in different balancing markets. So, but to get the possibility to realize and activate flexibility, it is important with digital and automatic solutions. And for the last, it is necessary with tools and incentives, as I said, contributing to get these new flexible resources. And also we are working with a further dialogue and cooperation. It's important for the whole power business to cooperate to get this flexibility available. So what does Statnett contribute? What we need the flexibility, and we want to inform. So related to market participation, we will make it easier for stakeholders to participate in and see the benefits in our balancing markets. We are also working to make it easier to utilize flexibility across all grid levels with cooperation between DSO and TSO. And also we are working to establish, to make it easier to establish bilateral agreements about flexibility. But that's also if we have the customer connection, or if it's the DSO that has the customer connection. And also we want to contribute to a more beneficial development of regulations and supporting schemes, so to get this proper framework for utilizing flexibility. For what we see in the future power system, the consumption has to follow the generation. And that is a major change from today's power system, where we see that the generation is following consumption. So that's my last slide. So thank you for your attention.
Thank you very much, Anne. Thank you very much. It was a pleasure to kind of set the mood for the presentations that are coming. Many interesting inputs, such as, of course, the need of flexibility. The need of flexibility is something that we've been working with for the past at least 10 years. But the key concept here is that we are also looking at new stakeholders. We need to involve new stakeholders, and this has been the real change when it came to energy flexibility of industrial processes itself. And then, of course, the role of enablers and the business models that they do need to follow. So thank you very much again, Anna. Now what we're going to do is we're going to walk through the 3 projects. Each project is going to have a project presentation by a relevant partner. Then there's going to be a presentation of the use case, and then there is going to be a Q&A session that I would like to run as follows. So you can feel free, if you are allowed to, I am not sure, to write questions in the chat. If not, you can ask it at the end of the session just by raising your hand. We will try to keep it nice and short so that we leave time for the interaction. And I don't want you to hold back on that. So if you have any question, any doubt, any curiosity, we are here to try and respond to that. So the next piece of session is dedicated to the Trineflex project. We're going to have Filippa Lima from IMEN and Matteo Marini from Verallia. They are respectively the coordinator of the project and one of the key use cases of the project. So please feel free to start, guys.
Hi, everyone. Just testing if I can't go back. Can you put in the first slide, please? Yes. I will test if I can control. Sorry. I think that I don't have permissions to control the slides, only to make zoom in or zoom out. It's normal.
Let us check. Give us a second.
Maybe it's easiest if I just go to the next slide for you, so you can just
Okay,
let me know.
so I ask you. Sorry. Okay, so hi everyone. As you already know, my name is Filipa Lima. I'm from IMAN, and during the next few minutes, I will introduce you to the Trineflex project. Well, if I have to resume the Trineflex project in one sentence, I would say that Trineflex aims to support the transformation of energy-intensive industrial processes through the integration of energy flexibility, having as ultimate goal the climate neutrality by 2050. Next slide, please. So starting with a very important information, which is our consortium. We are 29 partners from 9 different countries, and super important between these partners, we have 5 huge resource and energy intensive industries, which are in fact our end users. And their participation is very important when to accomplish with our objectives, especially those ones related with the transferability of our methodology. And I just want to say that this project just started last year and should be finished by 2026. Yeah, next slide. Well, as I said, Trineflex wants to contribute to speed up the transformation of energy-intensive industries, and this will be done by demonstrating the viability of merging the digital transition with transformative energy technologies. So the goal is to show that this synergy will allow the development and deployment of toolkits to be used by these industries, which at the end will allow the exploitation of their flexibility potential, reducing energy demand, peak demand, energy costs, and of course, to contribute to become climate neutral by 2050. Well, today I don't plan to tell you much about technical developments. I will leave that for future webinars where with more time and more results, it will be easier to show the applicability of the project. But since we are in the first year of the project, it's important to tell you what are our main objectives, those objectives that always guide Trineflex work. And you can see, oh, sorry, previous slide still. They are represented here in these dark boxes. And the first one regards the delivery of a digital retrofitting process, where the main focus is on the flexibility potential of each demo site. Then digital twinning and validation. The idea of this project is to deploy a methodology based on an adaptable process to develop a digital twin and integrate in it technology models, reducing in this way the risk of investing in new solutions. Third objective is related with the development of multi-agent systems in a way to support flexibility both on the energy, process, and feedstock sides. The fourth objective is the basis of our entire project, and is to ensure that the whole project is aligned with the European Commission ethical values and the principles. And finally, to show that this is all possible, we'll demonstrate flexible and sustainable operation in our demonstration sites. And as I said, this will be demonstrated by maximizing the energy flexibility potential, reducing the dependence on fossil fuels and fossil feedstocks, improving efficiency, and also demonstrate that there is room for replicability and transferability of this methodology. Yeah, now yes, next slide, please. And this slide is just to give you a bit more details regarding this synergy between the digital part and the energy technologies part. So alongside the deployment of the digitalization, I mean the digital retrofitting and digital twin and so on, individualized energy transformative technologies will be explored and digitalized assets will be generated and integrated in the Trineflex platform. Regarding those energy technologies, I'm talking about, for instance, technologies capable of providing sustainable energy in closed-loop systems, about development of an energy distributed storage system to empower local and regional actors, about the integration of the use of hydrogen from different origins as feedstock, about, for instance, the integration of renewable energy sources in post-combustion carbon capture systems, among others. So the prior study of these alternatives and their introduction in the Trineflex platform will allow its evaluation, mainly in terms of potential towards energy flexibility and neutrality, of course, before any step of physical installation. Next slide. Thank you. And now our end users. As I already said, Trineflex methodology will be demonstrated in 5 resource and energy intensive industries, and they are from 4 different sectors, which will allow the consortium to show the adaptability of this project, of the process. But the most important thing is that these 5 demonstrators are fundamental players in future implementation plans, since due to their size and due to their geographic actuation areas, it will allow the rapid replicability and the transferability of results. And you can see here who they are. For instance, Verallia, an important producer of glass packaging, which has 32 plants, but about this we'll know more in the next presentation with Matteo. We have also Rafial working in aluminium recycling, Esamur and ADAP, 2 different entities from 2 different countries working in wastewater treatment, and Halcor, an important European player in the production of copper tubes, having, as you can see here, 16 plants. Next slide. And in this slide, we can see the main objectives by each of our end users. I will not enumerate them now, but I just want to reinforce the common objectives that we have for all of them, which are defining, realizing, and exploiting the flexibility potential of each one, reducing energy demand, reducing peak demand, reducing energy costs and emissions. And next slide. And finally, just to let you with the full picture of where we are and what are the next steps, in this slide we can see the generic methodology followed in this project, which of course have some modifications regarding each of our end users. So we are in month 14, as you can see with this yellow dashed line. And so we are still in the first phase of the project, which we call project design phase, where the main activities consisted of assessing end user requirements and potential flexibility, as well as assessing data acquisition, storage, and processing. Current ongoing tasks consisting of, for instance, in the implementation of the digital infrastructure for real-time data acquisition and the refinement of the digital twins architectures. These constitute the transition for the second phase, which is the integration phase. In this second phase, these will be finished with development of several designed digital solutions, and their validation will marks the transition for the third phase, where all the integrated digital solutions will be commissioned and demonstrated in operational conditions at our 5 demos. Well, I just want to say that in parallel to all these technical actions, we have other important actions, which are represented here in the bottom in green, which regards horizontal activities, such as, for example, stakeholders engagement, regional assessment on the availability of local energy, on the availability of fuels and storage, and for instance, the development of a gender equality plan, among others. And next slide, please. And for today, that's it. That I planned to present to you. If you have any questions, comments, if you see the possibility of any collaboration, we are available through any of our channels. Thank you for your attention.
Thank you very much, Filipa. I think we can go to Matteo in the meanwhile, there was a question that was responded to in the chat, but we'll try to summarize it at the end of Matteo's presentation. Please, Matteo, take the floor.
Hello, everyone. I'm from Verallia. In Verallia, I am the responsible for the energy management system of the Italian branch, and I'm also the leader for the project leader for Trineflex for the Trineflex use case. Next slide, please. Okay, something about Verallia. Verallia is a worldwide group which is a leader in the glass packaging sector, and we have a global presence in 11 countries with more than 10,000 employees. Verallia Italia is the Italian branch of this worldwide company, and it is formerly the Italian branch which is participating to Trineflex as partner. In Italy, we have 6 production plants, and we have more than 2,400 employees. We have a strong social and corporate social responsibility strategy, and we have officially declared as our purpose as reimagining glass for a sustainable future. And this purpose is based on 3 main pillars: enhancing the circularity of glass packaging, so in terms of recycling, decarbonizing our activities, and ensuring a safe and inclusive place of work. Next slide, please. This table is directly an extract from an official document that you can find from our corporate website. It's called the Universal Registration Document. This version is from 2022. I think soon there should be available the new one. And I might point you the attention to the first 2 rows that are a statement of the company objectives in terms of CO2 reduction in absolute terms versus the levels of 2019. In 2030, we aim for a reduction of 46% in CO2 emission, both Scope 1 and Scope 2. And then we have several other correlated objectives in the subsequent rows. But that's the most important one, and it is very ambitious. Next slide, please. Just to give an idea of how the energy is split in a typical glass production plant. So we can see the bar in gray is the energy consumed by the melting furnace. So most of the energy consumption in a glass production goes to the melting furnace. All the rest is divided in what is called non-melting energies, both gas, which is both powered by natural gas or electricity, and account for the remaining 26%. And they are split more or less on the same amount. So we have 13% for non-melting energy electricity and 30% of non-melting energy gas. As an order of magnitude, a typical furnace in Italy, which has 2 melting furnaces, consumes in the order of 500 gigawatt hour per year. So it is a very energy intensive industry. Next slide, please. For Trineflex, we will focus on 2 main steps of the production of the whole production cycle, or 2 processes. The first process is the 4 Rs or feeders. It has a different translation depending if you operate in France or in other countries. And the feeders or 4 Rs are the elements in which the glass flows from the melting furnace to the glass forming machine. And energy is necessary in order to maintain the glass at the correct flowing at the correct temperature the furnace and to obtain the right temperature for the glass forming machine. Each kind of bottle that has to be produced require a very specific temperature for the forming process. So how we will operate on this process? So first of all, new sensors will be installed in order to characterize better the process and to allow for the development of a digital simulation of the feeder in terms of their inner physics. So we would like to understand how the boundary condition of the process determine the temperature and the homogeneity of the glass which come out from the feeder and flows through the glass forming machine. This simulation will allow us to first of all optimize consumption, and then having let's say physical properties. This model will enable us to simulate what will happen if we make some design changes to improve even further the efficiency of the process or to improve its flexibility. In particular, what is under study is the possibility of installing an heat recovery system that will recover part of the energy which is flowing out from the feeders, from the chimneys, having a certain level of contribution to the heating part of these channels from electrical powered elements such as radiative elements or electrodes directly inserted into the glass path. And finally, another option is study and install a new type of more efficient burners. Okay, next slide, please. The second process that we will take into account within the Trineflex project is the shrink wrapping equipment. These are machines which are used to finalize the automatic packages of bottles and jar. You can see a snapshot picture on the right. Basically, on the stack of bottles on a pallet, polyethylene films are applied, and then heat is applied on the polyethylene through gas burners. And this makes the polyethylene shrink, and this in order to cover and stabilize the whole package. So what we will do for this process will be to first of all extract important information about the production cycles through a retrofitting of the existing equipment PLC. So the existing equipment, I remind to you, is again powered by natural gas at the moment. But then we will install a prototype of one of these equipment, which is where the heat comes from electrical resistance. This new equipment will be installed on the same packaging line, so it will be in series with the original gas-powered equipment, and this will enable us to make comparison in terms of overall energy efficiencies of the two equipments, and also to study possibilities of flexibility. For example, they could be turned alternatively, switched on or off, being in series, and so on. Furthermore, the data extraction will be, of course, available even from the new equipment in terms of cycles of the machine and so on. So another objective here is, of course, as for the feeder, is to reduce the overall energy consumption, regardless of it being, let's say, electrical vector or natural gas vector. Next slide, please. On the overall timeline that we have seen before as the general timeline of the project, we are at the moment in the position of being almost ready of transferring data from our own company, Process Data Historian, to the TrineFlex platform. So TrineFlex has already defined a standard common platform where the data will flow from every use case partner, and we are almost ready to start, let's say, the data transfer. And then all this data will be available to all project partners in order to start developing the model that we need for both feeders and shrink wrapping equipment in order to optimize consumption and study new technical solution possibilities. Little bit, let's say, in the future, but still next is the installation of the new additional sensors on the feeder that we need for the feeder models. And we are talking about glass height sensors and possible sensor that will measure the opening level of the chimneys. This will all occur before the end, hopefully before the end of this year. Yeah. Okay. And also the installation of the electrical power, the shrink wrapping equipment prototype will occur before the end of this year. Next slide, please. So, as what potential have all these actions? All these combined actions is expected to save up to roughly 10% of energy, working on the process efficiency. And if this approach is demonstrated at pilot level, so in the plant that we have selected for our pilot, it can then be scaled up at country level or even at corporate level. So what kind of saving are we talking about? We are talking about for the processes that we are taking into account at country level, we consume up to 200 gigawatt per year. So saving up to 10% of energy will translate into saving 20 gigawatt per year of energy. If we look at the emissions instead, these two combined processes, so the feeders and the shrink wrapping, amount to roughly 400,000 tons here of CO2 emitted from natural gas. So that means scope 1 CO2 emission at country level, and complete switching to electrical powered shrink wrapping equipment and combined with the energy optimization of the two processes will enable us to save up to 5,600 tons per year of CO2. And that is not considering the saving in CO2 if we manage to implement some partial switching of the feeder process from gas heating to some hybrid part of electrical heating of the process. Next slide. I believe that was the last one. Yeah.
Very good. Thank you very much, Matteo.
Thank you for the attention.
This was a very interesting dive, let's say, in the TrineFlex project. I think that well, it's interesting to look at companies such as Verallia that do have a function dedicated to well, energy management in general, as it is a big issue in terms of, you know, opportunities, in terms of also what a company that does something that has very little to do energy but does use energy can do to grasp, you know, to grasp opportunities related to energy flexibility. So I would try to go directly to the next session and do just one big Q&A session at the end, because I've seen that the questions are running in the chat and we are running a bit late. So I would leave it to the Flex Industries project that is going to be presented by their coordinator, Bruno Sodiro from Rina Consulting, our Genovese neighbors. And the use case is going to be from the Ford Otosan demonstrator from Turkey, and it's going to be Mehmet Alper. So Bruno, you go first.
Perfect. Okay. Thank you very much, Marco, for the introduction. First of all, I just want to give a quick thanks to Standbys for organizing this workshop. It's upon a reviewing period, it's nice to have this opportunity also to see how other projects are doing and to find some synergies about it. So next slide, please. I will try to catch up with the time as well. As you know, Flex Industries is a project also found in the same call, but that's why we're here. 35 partners from 9 countries around Europe and in this case also Turkey, Asia. We have a project of 48 months as well. We did finish in 2026 with a 12 million funding for the Process for Planet partnership together with the European Commission, a total budget of around 17 millions. So next slide, please. The project objectives are really in line with what other projects have explained or with the introduction. What we are seeking is elaborate a flexibility assessment methodology for industrial partners. We've seen in this like 18 months of project that there is not like a clear view of how to understand flexibility at the process level. So we expect that with the project we will be able to deliver also this kind of support. What we would like to do as well is to improve the connectivity between what is the IT world and the OT world, aka the operational technology, which is actually on the field, and to see how they can allow the activation of flexibility at industrial environments. We would like to do as well, and we pursued a lot in Flex Industries, is to deliver this dynamic energy and process management platform, and that then I will go a little bit in detail to allow the activation of process flexibility and allow stakeholders to understand how they can interact with the market at different levels, but not only like energy market in terms of electricity. We're exploring the possibilities of having some interactions between other type of energy markets, as in this multivectorial future that we will have. We will have several interactions with TCOs and DCOs also from district heating networks, and also hydrogen related networks. So we've seen that there are many opportunities for that, and we are pursuing this holistic approach for the whole industry. One important point of our project, of course, is demonstrate the innovations that we are pursuing to take them to at least a TRL of 7, because they will allow for replication and also the market uptake that we're following. We would like also, as you know, like one of the main aspects to allow and to bring flexibility to industrials is like to design and to change business models and business cases that they have in consideration the industrial energy transition for energy intensive industries. So we are working a lot on bringing that to earth, let's say, to adapt them and to change them. Next slide, please. The ambition of Flex Industries is quite related to what we have been speaking. Of course, the main points here are to develop the bottom to top approach, which is the one on the right compared to the one on the left. We've seen that the main actions have to be taken at industrial level, but also they have to have a lot of coordination with the top level. So this means that in order to allow industries to get into this dynamic, the focus has to be in creating this holistic multi-level and multi-scale approach that we call, that recognizes the complexity of the industrial environments and seeks to approach the industry from a multi-level, let's say a multiple level vision that has consideration of the devices, of the processes, of the value chain, but also at a multi-scale, which includes operating, tactical, and strategic. In this way, by providing stakeholders the tools and the means to allow them to participate in flexible markets, they will make a positive impact on the whole energy system, and they will be able to utilize the EMS in a better ways, contributing to the whole energy system. A little bit, next slide, please. Sorry. A little bit of what I was talking before, like we focus in these 4 pillars. At this moment, we are working mainly in what is pillar 2 and pillar 3. The process adaptation is one of the challenge that we are facing currently, and I think that the other projects also can see that somehow there is a gap between what the project is, what the process is running, and how it can be adapted to feed data to a let's say higher level of information and processing. And then we're working on the pillar 3, which for us is the main let's say demo cases that we will have in Flex Industries. Next slide. Okay, this is a mapping of what we are actually doing in Flex Industries with the demo sites. As you've seen, we cover most of the energy intensive industries, and we are like quite dispersed around Europe. So this brings like good opportunities for replication and to assess the whole situation in different countries. The interventions that we are actually making at RES integration, waste heat recovering, and energy management systems. As you can see, we most cover the whole spectrum with all the demo sites, and this will allow us to validate. Next slide, please. Validate these 7 innovations that they are more related to what I was like talking before. Waste, we are implementing a lot of waste energy recovery options, and with the lower TRL around 5, and we expect to have them at 7. The replicability of these innovations is quite interesting, and we are supporting the integration of these innovations together with the energy management systems, which will be included in, next slide, please, our main result, which is the dynamic energy and process management platform. As you know, the call that found us, it's digital twin. So mainly the approach, as we all have here, is to develop this digital twin backend that has the potential of managing real time data from various sources. That in this case, in Flex Industries, the approach is like from IoT devices connected to what we call a field layer. So getting real data of the process and assessing how that data could have an impact on the flexibility potential of that process, and at the same time providing the stakeholder who is using the platform a decision support system able to assess them in the decision making towards activating flexibility or demand response services to the TCO, to the DCO, according to their needs or according to their strategic planning. So Flex Industries, it's mainly focusing on making this platform highly replicable, highly adaptable. Today, next slide, please. Today we found ourselves on the month 17 of the project. What we've seen, it's the main aspects that we've been covering was like the characterization of the whole process. We working with 7 demo sites. It's been quite challenging because we had to organize ourselves in very good ways and to dispose a whole harmonized methodology to do that. What we've been doing as well, which is really important for a project like Flex Industries, is the definition of harmonized KPIs that are applicable and replicable for the future monitoring and demonstration activities. That will be a great effort of this project. And what we have achieved lately is the conceptual designs of the solutions that we are implementing based on all the data gathering phase that we have during the first year. Next slide, please. So as we are entering this second phase of the project, what we are now facing as the final architecture of the platform, after having some feedback between demo sites and developers, we find that we could have some tune regarding to what was thought during the proposal phase. So we are in this process of this retrofitting process of adapting also towards the expectations of the stakeholders. We've seen a great challenge in the cross-sectorial adaptation of the platform, because different process and different industrial environments create those challenges, of course, of making something that is highly replicable, adaptable to the solutions of the needs. So there's a great input that we cover a whole spectrum of 7 different industries. We are entering the prototyping phase of the solutions, and as you know, like so we've been talking, the definition of business cases and business models to address the industrial-oriented flexibility service to the grid, and to see how they are compatible and how they can be coordinated with the players on the market is a challenge that it could be interesting to explore with other projects in the future. And we enter in also implementation phase, which is very challenging phase, and of course it will include a great effort from partners. So it's a whole presentation for the project. Thank you.
Thank you, Bruno. And I think that now we can go to the use case demonstration from Mehmet. I will ask you to be as quick as possible, because this part of the session was supposed to, well, actually, let's just say that we are running a bit late. So if you could try to squeeze it into maybe 6-7 minutes, that would be optimum. Okay?
Yeah, that's
Thank you
good.
very much.
Yes. Hello, everyone. I am Alper. I have been working for Tutasan as a data scientist. Today, I'm going to present Flex Industries project as a perspective of Ford. Next slide, please. Ford Otosan is one of the top 3 exporting companies in Turkey and also automotive industry leader. And Ford Otosan has 4 different plants, such Gölcük plants, Yeniköy plants, Craiova plants, and Eskişehir plants. And we manufactured that 3 different type of vehicles: commercial vehicles such as transit and custom, passengers vehicles, Puma, and also Ford trucks. And also we have 2 different research and development center in there. Next slide, please. In the main challenges in Ford, consuming large amount of electricity and natural gas, and also lack of real-time energy monitoring in paint shop. So that's the reason why we are participating in Flex Industries project to achieve and reach the our goals, such as increasing the green energy capacity in our plants and also increasing data-driven energy optimization models. Next slide. We mainly we are 2 main responsibilities in there. One of them is paint shop use case. After we analyzing the whole data in the paint shop, we decide to focus on phosphate and electrocoat boot because phosphate and electrocoat boot consumes much more energy compared to other zones. In the actual states, in the current states, we couldn't monitor the efficiency of heat exchangers in the boots, and also there is no any alert mechanism in the critical point in the boots. So we are adapting some additional sensors in the area to reach maximize heat exchange in economizer and also optimizing boiler and analyzing the actual boot temperatures and give an alert to process them in the abnormal conditions. Next slide. How can we do that? I mentioned it. We implement some sensors, such as we collect the data from economizer, heat exchanger, and also boots, and we store this data to Bitac Sapphire cloud system, and we share this data from cloud system to our partners who develops models and optimize the system. Next slide. And we analyze with Cartif and CIRT energy consumption in the paint shop. And in the current state, generally manual control of equipment according to maintenance table and unpredictable breakdown is common. During this project, our aim is detecting anomalies of transformers as a real time and giving alert to maintenance team, and preventing failure modes in early stages and minimize the electricity consumption in paint shop area. Next slide. Another significant goal as a Ford, we want to increase our renewable energy sources in our facilities, such as construct a solar wall in paint shop, body shop, and assembly line area, and also integrated photovoltaic panels. And we working on designing a battery energy storage system. This battery energy storage system contains completely use of the primary use, and that's common in the second usage of the batteries. Next slide. To sum up, our demo actions and demo targets are improvement, monitoring infrastructure, and implementation of Flex Industries platform, 3.68 megawatt photovoltaic plant integration to green local energy supply, and also construction a solar wall in the body shop and assembly line, and implement a battery energy storage system to charge electric vehicles before they are shipped, and also communication to grid operator and connection to grid platform. And our target is 4% reduction in natural gas and electricity, and 7 times increase in renewable energy sources in terms of primary energy, about 2.4 ton carbon dioxide reduction, and also and about 2% energy cost reduction. That's all. Thank you for your attention. Thank you.
Outstanding, outstanding, really. Thank you for catching up with the time so much and for the thorough presentation. I think that seeing, you know, the big players kind of focusing on these aspects and realizing that, you know, it's a balance that needs focus and that needs work to be achieved. It's really fascinating. And now I would say that we can move to the third project of that was funded under this call. So I will actually you know take off the role of the moderator for this session, and I will leave the floor to Chiara Caccamo from SINTEF, who is the technical coordinator of the project, and to Ragnhild Eleftheriadis, who is coordinating the Flex for Fact project. So, ladies, I will leave it to you, and thank you very much for the presentation.
Yes, thank you very much, Marco. Yeah, we will catch up with the time. I will be quite quick, and I will leave the floor to Chiara quite into this PowerPoint. So just keep on. Next slide, please. We go slightly through this ones because we do have already said that this is into the process for partnership, process for planet partnership. We have a goal that we are going to come to an end of an ecosystem for multi-level architecture, and this is concentrated around the digital twin solution. So for FlexFact, the main goal is the ITC area. Yeah, we are having 5 different demos, especially into the high industry or process industry, and also into the discrete manufacturing industry. So we see this is more or less a shared one where we can share the manufacturing as a possibility also for those who have high energy intensive industries in that area. So next slide, please. That's a little bit about what we are going to develop. We are going to develop some small microservices and solutions for environmental friendly production. And especially the demand part of it, of the energy is important. Also to valorize the excess of energy streams. And for us is this to offer the demand response. And when we are looking at this is more or less into the digital twin, where we could also have this as a energy flexibility during this, and also the operations around that, and that's especially for the control systems in this area. And to foster creation of energy communities, this is also a part of our goal in the project. So next slide, please. Here you can see slightly the consortium. We are 23 partners from Spain, Italy, Germany, Ireland, and Norway, and we are a very hard group of partners, because as you see on the right side, you have Standard Profile and Celsa, which is process industry, and on the other side you have the typical manufacturing industry. We have also some high level academic partners and technology providers that can help us with going into this dig deeper into this. So I want to let the floor to Chiara for the development of the solutions that we have already started to progress. Please.
Thank you very much, Ragnhild. I will be glad to guide the audience through the technical aspects of the project. So we started in November. It will be almost 1 year and a half from the project start. So we have been doing quite some stuff. So we started with the assessment of our 5 use cases because there's would represent the framework, the scope of work of the project. And at the same time, we have been working on the Flex4Fact system reference architecture, which has been recently delivered. We have been working on the decision support tool, Sunflex toolkit, based on Sankey diagrams, and this will be used also later on in the project. Compare baseline and the results obtained. We have also focused on energy market study, also focusing on aspects for trading between EU countries, European countries, and assessing demand side balancing services. And currently under development, of course, we are progressing with the aggregator platform, with the digital twins, and an example we'll see later on with the SEAC use case, and with the flexible scheduling algorithm. So we have already developed, let's say, the general principles, and we have tailored already this algorithm for a particular use case, close to 2 out of 5, and we have defined also actually the variable needed in order to feed these algorithms. Please, the next one. Yeah, so very interesting fact. Like I've seen also in our sister project, the type of use cases. We have quite different ones from different sectors. So we have a standard profile from Spain in the automotive sealing systems. So this is extrusion processes. We have Celsa, again in Spain, for steel production. So more melting and extrusion of steel. We have SEAC from Italy, where they produce diving equipment. So here again we speak about molding injection, electric injection molding processes. We have Inavinta Solar from Norway, where they produce the solar collectors based on high performance polymers. So again, we are speaking about extrusion lines with different type of materials and welding line. Finally, we have Teben in Germany, where they produce their leader in the production of smart home systems, in particular electronic switches. So here we have also an example of mass production in electronics. Next slide, please. Yeah, so the technical standpoint, I want to focus on the fact that the data is really at the heart of Flex4Fact. Like we mentioned at the beginning, we share many common objectives and ambitions with our sister projects. But while on the energy efficiency side, or possibility to include generation and storage locally, that will be analyzed through this decision support tool, the Sunflex that I was mentioning before. The data are really important because the overall objective is to study the processes and trying to implement the main concept that also Hanne introduced at first, which is change the the paradigm of generation following demand, and rather have demand more flexible and following the generation and the variability of the generation when it comes to renewables. And this is done at different levels. Fortunately, in the project, we have this use case also differentiate in terms of the flexibility that they can offer. Because in a couple of cases, we are really studying the process and see how the process parameters can be varied without affecting the product quality. On the other hand, we focus more on the scheduling algorithm, so the possibility to vary the schedule through different products. I mean, having also the possibility to install, so to exploit local generation and storing. So it's very different approaches. And in the project, we will go through all the main aspects of from data mining to data management, generalization, and transfer learning. Next, please. So remaining on the same subject of the data, what we have realized very early in the project is that the scale up is quite the key to realize the maximum benefits. So in many cases where maybe the process itself doesn't give too much flexibility, actually the possibility to extend the solutions to a whole production line, to a whole plant, or maybe also to many plants in the same country, allow to reach a significant benefit. So in this sense, when studying the architecture, when studying the digital twins, we are focusing already on the data models, granularity, and the methodology for the developments of such models and such algorithms in order to start thinking about the scale up. Also, in a way, some use cases have already set targets for the whole plant or several plants in the country. And this continues when we think about generalizing to other industries. And in a way, I believe that a basic ambition is really have a high adoption of such solutions. And I believe this is true for us, for any kind of other projects working in this respect. So here, I want to stress the importance of having data models, algorithms, process models that can be generalized. And I believe the ultimate goal would be also to have a kind of data universe for industrial flexibility. So I hope that this is, I mean, starting with this webinar, we will continue also with our sister projects, sharing our findings when it comes to how can we extend our solutions and actually to put in operations data spaces and other considerations that have been done so far in the past. Because like Marco said, I mean, stakeholders have been working in these aspects, in this subject, at least since 10-15 years. So it's really, we are really now coming to the time of where we need to operationalize what we have and to close the gaps of what is missing. Next, please. I don't remember if there is another one. Actually, no. So thank you very much for your attention.
Thank you, Chiara. And I think now it's my turn. I will try to keep it as brief as possible. Here, I am representing SEAC Sub. That is one of the use cases that Chiara already presented in the FlexForFact project. Stam, in particular, is the technical leader for the SEAC use case. And so here I'm trying to tell you the not really much for how SEAC is serving the project, but how the project is serving SEAC in terms of, their green transition strategy. So we can go to the next slide. We will start with the SEAC's history, a history that led them to participate in the Flex for Effect project. Then their goals within the project itself, the ongoing activities. As you said, the project's been going for the past year and so. So there's a lot of things going on, but good thing, there's also already a few results that we are really proud of and that are really serving the company right now. Next slide, please. Okay, so real quick, like Chiara said, SEAC Sub is an Italian SME with a turnover of around 15 million euros, specialized in the production of underwater sports goods. Although they're, like I said, an SME, they manage to compete in certain market niches with the big guys, thanks to their quality, thanks to the quality of their products, thanks to their Made in Italy brand, and thanks to their, let's say, innovative and evolutionary business models that they've tried to change, pivot, and evolve since their foundation. For this reason, in 2019, so before COVID actually hit, at that time, their production was mostly overseas in Far East. And in 2019, they realized that this was lowering the cost of production, but was also making the production itself and the quality of products extremely variable. Not so good if you're pointing, to become high-level quality and be that your strong suit. So they started the reshoring process, where they actually bought injection molding machines to produce especially the top-tier quality goods in their factories. So this led to an increase in the employees, to an increase in the operational activities here in Italy. And then what happens is that COVID hit. And so, of course, they had more employees due to the reshoring that they couldn't have work because of COVID. So what they did was they experimented with the first round, let's say, of flexibility and resilience. So they tested some repurposing of their manufacturing so that they would be able, A, to stay open, and B, to provide support to the COVID pandemic's crisis through their full face masks that were used by doctors all over Italy. This supported them and allowed them not only to survive during COVID, but to grow and to grow as a people-centered company, and allow them to focus more on reshoring. And they increased by 30% their Italian, let's say, production capacity. Then what happens is that, of course, this led to an increase in the energy consumption in 2021, and this was a big increase. But then the war happened, the Russian-Ukrainian war happened. And so not only they were consuming more, but they were paying energy much more. So this put them in a position where they either had to decide, either die or survive. And they decided to survive and invest in a massive RES deployment. And now through the Flex for Effect project, they're leveraging this RES to go towards the so-called full flexibility. So being able to tune their production, their goods production based on their energy production capability and on the flexibility. Next slide, please. Yes. So, of course, they are a business. So even though the introduction was very romantic, their goal is to fulfill order, being able to forecast their energy consumptions and the costs, of course, being a key component in their business model, maintain quality standards, this is paramount, and maintain or, in some cases, reduce production costs. The objectives within the projects were to reduce energy consumption, finding bottlenecks and anomalies in the consumption itself, being able to forecast energy self-production capacity, meaning when am I going to be able to use my own energy for the production. If possible, detect energy flexibility sources within the production process, the molding process that I've mentioned, leverage that flexibility to increase self-consumption for their production capacity. Next slide, please. So what's been done to achieve these objectives, to serve this? So on one side, of course, there was a foundation of digitization that went through the whole process of SEAC. You can see here their production, which was very traditional. It was digitalized to a certain degree, but I think that the key asset of the FlexForFact project was that it kind of sped up very much the digitization process of SEAC. Also, it increased their capacity for energy monitoring. So innovative devices by one of the project partners called Aingura for energy monitoring were installed. This allowed us, on one side, to test the easiness of installation, so they were literally plug and play. And on the other, it gave SEAC the possibility of seeing their energy consumption with a time granularity that allowed them to, well, basically boost their decision-making skills and capacity, as we will see in the next slide. Moreover, this allowed to integrate the PV in their production and to develop their process and PV digital twins. So figuring out, with a focus on energy, how much each machine was consuming, what was being produced linked to that consumption, and what was the energy production on one side, the monitoring side, but on the other, the potential, so the forecasting of the potential. So all of these bits and pieces allowed to, even just 1 year into the project, achieve a few key results, a few interesting results. Next slide, please. So on one side, we're not saying that SEAC was not monitoring their energy consumption. It's just that they were doing it with a very low granularity. We increased their capability by 900 times, which actually was a pretty, a pretty game changer for them. Then, of course, the deployment of the RES happened. So this actually improved their self-consumption capacity because it improved their self-production. This was launched in June. Moreover, thanks to the monitoring capability increase, they've found the first bottleneck, basically. They realized that when the plastic is humid, or when the level of humidity in the plant is too high, the production efficiency goes to waste. And so it doesn't really make a lot of sense to plan to do anything in advance, because the material itself is not allowing for efficiency. So they introduced a drying step in the process. Actually, this is ongoing, but just by that self and choosing the right machine that is high energy efficiency, they were able to improve the overall efficiency by 15%. And then we were also able, through the foundation digitization process, to kind of support a very basic thing, that is figuring out what orders you're trying to fulfill, which up until FlexForFact was done close to manually, let's say. And now we do have a database that is allowing this, and that will allow to link the orders fulfillment to the production planning that is going to be linked to the RES production. So all in all, this is how pretty much SEAC was going into this direction before the project, and the project is speeding up this process by 900 times probably. So thank you very much. I think that we have 1 minute for question. If there's good questions, we actually can stay for a couple more minutes. Thank you very much all.
Thank you very much, Marco. Very nice example of how a project can speed up industrial progresses. Yeah, so just like Marco said, we can dedicate a few minutes more if we have questions. I see one hand is raised. So no, maybe not. Nevertheless, there are also our contacts in the presentation in case of some late thoughts. Any questions? You can also use the chat if you prefer. No one so far, so either we have been super boring or super clear. I guess there is nothing in the middle.
Probably so, yes.
Okay, then yeah, Caroline, what do you think? Can we? Yeah, let's see.
Ingeborg.
I have a very quick question. So this is sort of the first webinar to look at synergies between projects. Do we now, after the webinar, see some very apparent synergies and some areas where we can collaborate better?
Ooh, I would like also someone from the other project coordinators to reply, because I believe I already made quite serious statement in my presentation in terms of the need of catching up on the data universe based on the experience we make on the use cases we have in these projects. So I would like also to hear someone from, I see. Yeah, yes, please.
Yeah, from our side, mainly what we would like to explore with you as well and to synergize is the interfacing of stakeholders which are like outside of the project, which are the one that will benefit from flexibility, and to see how we can coordinate our actions towards maximizing these inputs. I've seen like we focus on the project of our processes, of course, but we don't have to lose the focus that we are aiming for a high penetration of renewables in energy intensive industries while providing flexibilities to the grid. So I think we could explore in other opportunities how our projects are addressing the flexibility and the remote response services to the grid.
Yeah, absolutely. And in this respect, I also invite you all to read the question and answers between Ingeborg and Hanne about flexibility, because that's very important too. And for example, on our side, maybe we are missing a little bit the perspective of TSO, DSO. So this is definitely something we need to explore more. And it connects with what you say, being sure, to involve also the stakeholders and the ones who will benefit from our solutions. And like you said, also the different interpretation we gave to flexibility. That's also very true. Yeah.
Okay, thanks.
Thanks to you, Ingeborg. Are there other questions?
Okay, if there are no more questions, I think, thank you to all the speakers for this very interesting webinar, and to Marco for moderating. Thank you very much, and have a good afternoon, everyone.
Thank you all. It was a pleasure.
Thank you.
Thank you very much.
Thank you.
Thank you very
Ciao.
much.
Thank you very
Thank
much.
you.
Thank you very much.
Thank you. Bye-bye.
Thank you.
Thank you. All the best.